Right, we have drawn the diagram for temperature and between pressure and temperature. So you can see the boiling point of different compounds we have drawn. So this is for ethyl alcohol. So it boils at lower temperature, right? And pressure should be 200 mm of Hg. And carbon tetrachloride boils at 349.1 1 Kelvin. It starts from below the 60 mm pressure. Similar for the ethyl alcohol, but its boiling point is higher than the carbon tetrachloride. And water boils at 373 Kelvin at a lower atmospheric pressure. So I have given the next point. A standard boiling point of liquid is slightly lower than that of the normal boiling point. Why it is so? Because 1 bar pressure is slightly less than that of 1 atmospheric pressure. Right. So normal boiling point of water is 100 and that of a standard is 99.6 degrees Celsius. Next point is at high altitude atmospheric pressure is low. That's why liquid boils at lower temperature in comparison to the sea level, right? Due to the less atmospheric pressure, it boils at fast. So it means pressure when is high, temperature should be required is high. When pressure is lower, temperature for the boiling point is also get lowered. So this is the final conclusion. So right up to this point. So let's see the points explanation. Boiling point doesn't occur in a closed container or closed vessel when it is heated, right? So it obtains the vapor pressure only, not the boiling point. On heating continuously, vapor pressure increases. At the first clear boundary is visible between liquid and vapor because liquid is more dense than the vapor. So you can see the difference between liquid vapor and vapor phase. As temperature increases, more and more molecules go to the vapor phase and density of the vapor rises. Right. So by increasing the temperature, more molecules to vaporize. At the same time, liquid become less dense. Right. So by increasing the temperature, vapor pressure molecules increases, but the liquid decreases. So liquid starts expanding apart. When the liquid vapor apart, then it is called critical temperature. Right. So liquid and vapor, when they are apart from each other at that temperature is called critical temperature. So right up to this point. Our next topic is surface tension. So as we know, liquids take the shape of the container, right? Liquids take the shape of the container due to the surface tension. Shape of container, right? And why do soil at the bottom of river remain separated but they stuck together when taken out? Why does a liquid rise in a thin capillary as soon as capillary touches the surface of liquid? All these phenomena are caused due to the property of liquid that is called surface tension, right? So all these phenomena, a molecule in the bulk of liquid experience equal intermolecular forces of all sided, right? So when liquids are in spherical form, they experience a force from all sides, right? Due to the intermolecular forces of this liquid. This is intermolecular forces. Right, the molecule therefore doesn't experience any net force, but for the molecules on the surface of liquid, net external force is towards the interior of the liquid due to the molecules below it, since there are no molecules above it. So you can see here on the diagram it is made. So up to here water is there. So at this point liquid force is acting horizontally and what? Horizontally positive and horizontally negative. So these are cancelling each other and downward force is acting with making an angle vertically. And this point is making all. Below the surface of this water, there is a liquid droplet on which force is acting and which is cancelling to each other, right? So liquid tends to minimize their surface area, right? So liquid always try to minimize its surface area. Liquid tends to minimize their surface area. Surface area. The molecule on the surface experience a net downward force, right? So liquids on the surface experience a downward force. Downward force at the surface. At the surface, right? And have more energy, right? And have more energy the molecules in the bulk. They do not experience any net force. Therefore, liquid tends to minimize the number of molecules at the surface, right? Due to the downward force, they tends to minimize their surfaces. Liquid tends to minimize its value. Minimize its value. Right. The energy required to increase the surface area of the liquid by 1 unit is called surface energy. So what will be the definition for surface energy? So write the next point. The energy required to increase the surface area of the liquid by 1 unit is called surface energy. The energy required to increase the surface area of liquid by 1 unit is defined as surface energy, right? So dimension of the surface energy will be joule per meter square. So right up to this point. So let's see the definition of surface tension in a proper way. So surface tension is defined as the force acting per unit length perpendicular to the line drawn on the surface of liquid. So next is surface tension is defined as force acting per unit length perpendicular to line drawn line line drawn on the surface of liquid, right? So this is called surface tension is represented by T and it is defined by force upon length. So this will be the formula and unit will be Newton per meter, right? And its symbol surface tension is given as gamma, right? Has dimension kg per meter square, right? So it is denoted by gamma. It has dimension kg per second a square, or next unit will be kg per second square. The lowest energy state of the liquid will be when surface is minimum, right? So when surface is minimum, that time surface tension will be minimum. Lowest energy state of liquid will be when surface area is minimum. When a spherical surface satisfies this condition, that is why Mercury drops are spherical in shape. A spherical shape satisfied this condition. So when lowest energy is minimum, when they are in the spherical shape, right? So a spherical surface have less surface tensions. Shape satisfies this condition. This is why sharp glass edges are heated for making them smooth. Right. For heating, the glass melt and the surface of the liquid tends to take the rounded shape as the edge. That makes the edges smooth. That is called fire polishing of the glass. Right. So that's why we do the spherical shape of the glass also. Right. Liquid tends to rise in the capillary because of the surface tension. So liquid wants to rise. Liquid tends to rise due to the capillary or rise or fall also in capillary. So it depends on the property of capillary also because of the surface tension they are doing so. Because of surface tension. Right. So complete up to this point. So next point is so liquid weight the thing because they spread across their surface, right? So liquid weight the things because they spread across the surface as the thin surface across their surfaces as thin film, right? Most of soil grains are pulled together because surface area of thin film of water is reduced. Most soil grains are pulled as the surface area of there is thin. Liquid weight the right are pulled together because surface area is thin. Surface area of thin film of water is reduced. Of water is reduced. It is the surface tension which gives a stretching property of the liquid of surface of the liquid. So which gives the a stretching property that is surface tension. So surface tension, surface tension which gives a stretching property, a stretching property, which gives the stretching property of the liquid. Right. Next is on flat surface, drops are slightly flattered by the effect of gravity. So when water is dropped or some liquid on flat surface, what happens? It flattened by the effect of gravity. Droplets are slightly flattened by effect of gravity. Effect of gravity. But in the gravity-free environment, drops are perfectly spherical. But when there is no gravity, its shape will be spherical, right? So, but in the gravity free environment drops are perfectly spherical, right? Next one is magnitude of the surface tension of liquid depends on the attractive forces between the molecules. So magnitude depends on the attractive forces. Magnitude of surface tension of liquid. Surface tension of liquid depend on attractive forces. Attractive forces. So write up to this point first.